The notes for Unit 4, Lesson 2 will cover significant figures. Significant figures are also called sig figs. So these are important in chemistry, and we will use them actually for the remainder of the year. So here's why sig figs are important. In chemistry, every calculation that we do, every piece of data that we collect is from a measurement. So it's either a mass or a volume or a length, or we can calculate the area. So every number that we use in chemistry comes from a measurement. So when we use significant figures, we are thinking about and taking into account how precise or how not precise the measuring device was used to get a specific measurement. So for example, if we look at the 3 scales along the top, this first scale, if you look at the number, it reads to the 1/10 of a gram. This second scale reads to the 100th of a gram. The third scale on the far right measures, to a 1,000th of a gram. So this scale is going to be much more precise in our answer than the first scale. If we look at our volumes for measuring, the beaker, we have markings for 50, 100, 150, 200, 250. So if we were to guess or estimate the volume of this liquid, we might guess that it's about 225 milliliters. If we look at the second picture, which is a graduated cylinder, if you look at the magnified view, we have markings at 60, 61, 62, 63, 64. So this measuring device, if we were going to measure this liquid, we know it's at least 67. So those are our known markings. But then whenever you measure something, you have to estimate 1 decimal place past your known values. So we might estimate that this is 67.1 milliliter. This last value, is your estimated or uncertain value. So you always have one value at the end that's an estimated value based on the markings. But if you have a measurement of 67.1, I can look at that measurement and know, okay, well, this device had a measuring or had a mark at 61, 62, 63, 64, 65, 66, 67, 68. So I can tell how precise or how not precise that measuring tool was by looking at a given measurement. All right, if we look at the last picture is called a burette, and that is very, very, very precise. We use that to get very accurate readings. So if we looked at this amplified view, you can see these markings are backwards. So 27 is here, 28 is here. So this liquid we would measure at, we know it's at least 27.6. So these are our known values. And then our estimated value, we would say it's 27.63. This is our estimated value. So if I look at this measurement, the burette measurement is measured to the 100th of a gram, where the graduated cylinder, the second picture, is measured to a 1/10 of a milliliter. So we can tell based on these two measurements that the measurement on the far right came from a more precise measuring tool. So that is kind of why we care about sig figs, because every number that we use in chemistry comes from an actual measurement, which comes from an actual measuring device. All right, here are your 5 rules for determining how many significant figures a given number has. So if you need to pause the video to write down the rules, you can, but I'm going to go through the examples for each one, talking through how you get those answers. So rule number 1 is that all non-zero numbers are significant. So in the example, if you have 34, the 3 and the 4, neither one are zeros, so they're both significant. That's where we get our 2 sig figs. The next example, 2,846, None of these are zeros, so we would count the 2, the 8, the 4, and the 6 to give us our 4 sig figs. All right, rule number 2 says that all final zeros, so final zeros are zeros that come at the end of the number and after the decimal place. So all final zeros after the decimal, so it has to be at the end of the number and after the decimal, are significant. So in the example, 34.00, the 3 counts, the 4 counts, because they're not zeros. These zeros would count because they are at the end of the number and after the decimal. All right, if you look at the next example, 3.00, the 3 would count because it's not a zero. And these zeros are at the end of the number and after the decimal, so they also would count. That's where you get your 3 sig figs. All right, number 3, all final zeros without a decimal are not significant. So if you have 100 and there's no decimal in this number, these zeros are just placeholders. They are not considered significant. So they are just placeholders to show how big or how small the number is, but they are not counted as significant figures, so this would only have 1 sig fig. Same thing with 2,550. This 0, because there's no decimal, is a placeholder. So we only count the 2, the 5, and the 5 to give us our 3 sig figs. Now, it doesn't mean you don't need the 0, because you still need the 0 as a placeholder. It's just not counted as significant. All right, rule number 4, zeros in between 2 other significant figures are significant. So in the example, 50,007, the 5 and the 7 are counted because they are not zeros. All of these zeros in between would also be counted because they are zeros between 2 other significant figures. So that's where we get our 5 sig figs. The next example, 10.0, the 1 is counted because it's not a zero. This 0 at the end of the number applies to rule number 2, so it is a final 0 after the decimal, so that does get counted, which means that this 0 in the middle also gets counted for a total of 3 sig figs. And rule number 5, all leading zeros, so leading zeros are like when you look at a number and it starts like 0.000, those are your leading zeros. Leading zeros are not significant. Again, they are just placeholders. So these zeros, again, you need them because it has to show how small the number is, but they are not counted as significant. So that would just give you your 1 sig fig. The last example, 0.00340, those leading zeros are just placeholders, so we don't count those. We count the 3, we count the 4. This final 0, whoops, is a 0 at the end of the number and after the decimal, which applies to rule number 2. So that is counted. That's where you get your 3 sig figs. Oh my gosh, sig figs, so much fun. All right, so in this example, these examples are in your notes. So take a second, pause the video. You are trying to figure out how many significant figures each one of them has based on the rules. So pause the video, take some time, and then come back and check your answers. Even if you get all of them wrong, it's okay, as long as you try to understand those mistakes. All right, here we go with the answers. Number 1, 7.1657, none of those are zeros, so they would all count as significant. Whoops, so this number would have 5 significant figures. Number 2, 800. So 800, because there's no decimal place, these zeros are placeholders, so they do not count as significant, so this value would just have 1 sig fig. If you had a number like 800 point, now that decimal makes these zeros significant because it means that that measurement is exact to the point, so that would give us 3 sig figs. So you have to be careful about when the number has a decimal and when it doesn't. All right, number 3, the 1 and the 2 are significant because they're not zeros. The zeros in between are also counted because they're in between other significant figures. So this would have 4 sig figs. All right, number 4, we start out with leading zeros. So leading zeros are just placeholders, so they are not significant. So we would count the 7 and the 8 for a total of 2 sig figs. All right, number 5, 88.0. The 8 and the 8 are counted because they are not zeros. This final 0 is at the end of the number and after the decimal place, so it does count. So that would be 3 sig figs. And in that case, the 0, the final digit, would be our estimated value. All right, last but not least, number 6, we have 100.0. So the 1 is counted because it's not a 0. This 0 at the end of the number applies to rule number 2. So final zeros at the end of the number and after the decimal count. And then these zeros in between also count. So this would be 4 significant figures. All right, so the second part of your practice in the notes has you round a specific value to 3 sig figs. So each time you round, for now, the question will tell you how many sig figs to round to. When we start doing sig fig math, then you'll have to look at your numbers and determine how far you round your answer. So the thing that you have to be careful of when you're rounding is your final answer, your rounded answer, has to be somewhat close to the original value. So for example, number 1, we have 5,692,738. We can't round 5 million to 500 or to 50 because that's not even close to the original number. So the size of the number has to be somewhat close to the original number. So here's how I look at numbers to round them. If I need 3 sig figs, I start from the left and I'm going to count my first 3 values. So I need to keep the 5, the 6, and the 9. Those are my 3 digits. Then I look at the 4th digit to see, is the 2 big enough to cause the 9 to round up? So usually if the number is 5 or greater, then the previous number would round up. In this case, a 2 is not going to round that previous number up. So I'm going to keep the 5, the 6, and the 9. Those are my 3 digits that I'm keeping. All of these other values get rounded off to zeros, so they can be placeholders to keep the value of the number somewhat close to its original value. So our original number rounded to 3 sig figs would be 5,690 milliliters, or 1,000 milliliters. All right, number 2, 0.62038. Again, I'm going to look at the first 3 values. Those are the 3 values that I want to keep. I look at the 4th one to see, will the 3 cause the 0 to round up? Nope. So then I'm going to keep the 6, the 2, and the 0. And because this 0 is at the end of the number and after the decimal, it would count as a significant value. So this would be my 3 sig figs. So 0.620 would be my final answer. All right, so take a second to pause the video, try the last 3 on your own, and then come back and check your answers. Again, even if you get every single one wrong, it's okay because we'll just keep practicing away. All right, number 3, 100 liters. So since the value of 100 does not have a decimal place, those zeros are just placeholders, so they do not count as significant. But to make this into 3 sig figs, we could just put a little decimal at the end, and that decimal means that this number is exact to that point, so then those zeros would count. Number 4, if you had 3 centimeters, 3 centimeters only has 1 significant figure, so we need to make it into 3. So since 3 is a whole number, we can add a decimal. And then if we put 2 zeros at the end of the number and after the decimal, those zeros would count. So that would be our 3 sig figs. All right, and the last one, number 5, 0.001. These are leading zeros, which again, you need them in the number to show that the number is really small, but they're not counted as significant. They are just placeholders. So for our answer, we need to make this 1 sig fig into 3. Because there's a decimal, we can add 2 zeros at the end of the number and after the decimal to make this 0.001 into 3 sig figs. So your final answer would be 0.00100. So hopefully you took some time to try them on your own. We'll do a lot more practice over the next few days, and these rules will totally start to click and make sense.